Hello everybody, welcome to the Epic Flight Academy. This is the Private Pilot Ground School course and my name is Mike Thompson. Our topic today is wind. Now, as we study wind, please be sure you are working through Epic's online course. These videos parallel that online course content. And then finally, you must review all of this content one-on-one with your flight instructor. So let's talk about wind. It's something I think a lot of us take for granted. We're going to start with this diagram from Epic's online course. And here you can see a high pressure area in the top of the diagram and a low pressure area in the bottom. The high pressure area shows the wind moving in a clockwise direction and slightly outward from that high pressure. The low pressure diagram shows the wind moving counterclockwise and slightly in toward that low pressure. Now, memorizing that for rote is one thing. Understanding exactly why that works that way is important to a pilot, and that's the subject of our video today. Wind results from three forces: PGF, Coriolis, and friction. So what's PGF? PGF is the pressure gradient force. Now in this diagram here, you can see this high pressure system up over southern Canada and this low pressure system over the Midwest. And on this diagram, we see these concentric rings. These are isobars. Iso means equal, bar means pressure. These are lines of equal barometric pressure, or isobars. Now, wind will naturally flow from high pressure to low pressure. Nature is going to try to fill that low pressure area, and we are going to feel that as wind. Now, when we look at these isobars, that pressure gradient force is stronger when the difference between high and low is greater. I want you to think of that like a steel plate with a steel ball on it. If I incline that plate, that ball rolls off. Now, the steeper the incline on that plate, the faster that ball rolls. A steeper incline on that plate would be like a greater pressure difference between high and low, and that would be a steeper pressure gradient force. So just like that steel ball took off faster, the wind will blow stronger. Now, the second key factor to wind is the Coriolis force. You remember from an earlier video where I was standing up at Santa Claus's house in the North Pole and I kicked that soccer ball all the way to Brazil? Okay, that's this diagram that's in your online course, and this describes Coriolis force. In the northern hemisphere, Coriolis force always acts to turn to the right. Now, it's important to understand that as the pressure gradient force gains strength, in other words, as the wind gets stronger, the Coriolis force gets stronger as well. So, here in this diagram, you can see as air flows from high to low, Coriolis gains strength as the pressure gradient force gains strength. So we're showing our high pressure system, and you see where it says starting point, and the red line is nature's normal action to take that atmospheric air from high toward low. That's the pressure gradient force. As that pressure gradient force moves and starts to get stronger, Coriolis force also gets stronger, and you can see in our diagram here, it turns the wind, that's the large blue arrow, to the right until eventually pressure gradient and Coriolis balance each other out, and that wind is blowing parallel to these isobars. Now, I want you to think about that balance between Coriolis and pressure gradient, kind of like a hammer throw, okay? If I took this hammer and I were going to do the hammer throw, on our diagram here you can see that with a high pressure system, the centrifugal force of that ball, we would compare that to the pressure gradient force. And the centripetal force, which is that cable between the handle and the ball, we would compare that to the Coriolis force. So in a high pressure system, that pressure gradient force is like centrifugal, and the Coriolis force acts like centripetal. Now, what about a low pressure system? Well, the same forces are going to take effect, but if you take a look at this diagram, instead of the wind in the atmosphere flowing away from the pressure center, away from high pressure, they're flowing toward the low pressure. So in our diagram here, take a look where it says starting point, and again, that red line represents the pressure gradient as the air tries to fill that low pressure area, and again, Coriolis starts to turn it to the right, and once again, the stronger the pressure gradient, the stronger the Coriolis, and you can see here in our diagram, as that Coriolis starts to balance out that pressure gradient, they act opposite to each other, and the wind, that's the big blue arrow, is once again parallel to those isobars, but this time, as you can see here, in a counterclockwise motion around that low pressure area. So, if I take that hammer one more time and I swing that hammer throw out there, in this case, the centrifugal force is like the Coriolis force, and the pressure gradient is like the centripetal force, because that pressure gradient force is moving toward the low pressure. So you can see how our first two forces, pressure gradient and Coriolis, must work together. Now, there's one final force left, and that's called friction. And that is a friction between this airflow that we experience as wind and the ground, or the surface of the earth. Friction is stronger when the air is blowing over a rougher earth surface, and when the wind speed is higher. So the friction becomes stronger when the surface is rough and we have a higher wind speed. Now, here's the important key to remember with friction. Simply remember this: friction acts to weaken the Coriolis force. So take a look at this diagram. Here we show pressure gradient force moving toward a low pressure, and you can see how it's balanced by the Coriolis force, just like we described. And the large blue line is parallel to the isobars, just like we said. But because the surface friction weakens the Coriolis. You can see that happening here. The pressure gradient is slightly stronger, and around a low pressure turns the wind toward the low pressure center. What about on a high pressure? Exactly the same thing. The friction would weaken the Coriolis, and in that case, it turns the wind direction slightly away from the high pressure center. So that brings us full circle back to our diagram that we started with. Those three forces explain why in the northern hemisphere air circulates clockwise and slightly outwards from a high pressure, and counterclockwise and slightly inwards to a low pressure. Okay, folks, here's a simple quiz question. What are the three forces that come into play when we talk about wind? And if you said pressure gradient, Coriolis, and friction, you nailed it. Well, folks, we'll see you next time.